So OSPF, open shortest path first. Open shortest path first. Shortest path first, SPF, is an algorithm. It is not a routing protocol. Shortest path first is an algorithm. We also have different name for this algorithm. Definitely you might have heard about algorithm called binary tree algorithm, low cost path algorithm. These are all same thing. Dijkstra's algorithm. Dijkstra. Dijkstra is the name of a man who proposed this algorithm. Shortest path first is just an algorithm, binary tree algorithm, which picks one path, the shortest path, low cost path, among many other paths to a destination. But again, that is not a routing protocol. SPF is not routing protocol. SPF is just an algorithm that can be used to trace the shortest path when we have multiple paths to a destination. Now, this algorithm SPF is used to develop a routing protocol, and that is what we have here as OSPF. OSPF is one of the routing protocol that uses SPF. OSPF is one of the routing protocol that uses SPF algorithm. What is the other protocol that uses SPF algorithm? What is the other routing protocol that uses SPF algorithm? It is intermediate system to intermediate system. So both this protocol use the same algorithm to find the best path, and the algorithm is shortest path first. SPF is what used by these two routing protocols. SPF is not a routing protocol. It is used to find the shortest route by ISIS and OSPF. So Dijkstra's algorithm is SPF. Dijkstra's protocol is not a routing protocol. OSPF is not Dijkstra's routing protocol. SPF is Dijkstra's algorithm. Now, this SPF is not only used in routing protocol, it is used in various places like operating system to read the data from the hard disk using the shortest path. You know, your hard disk is full of data, various locations in your hard disk. To locate your data in a fast manner, Microsoft or the Intel the chipset, they all use SPF. They use SPF algorithm. So SPF is just an algorithm to go to a place in a quick using the shortest path, the nearest, the easiest path. OSPF is a routing protocol which uses SPF. ISIS is also another routing protocol that uses SPF. Now, what is that open? Why it is called open? Open shortest path search. This OSPF is an industry standard protocol, not a proprietary one. So It's open to use. There is no proprietary for this. You don't need to take approval from any vendor to use this routing protocol in your device. Every router will have OSPF, whether it is Cisco or non-Cisco. Every device, if it is called as a router, enterprises router, or it can be service provider router, or a data center routing device, all devices that is called as router will definitely have this protocol OSPF because it's an industry standard protocol. So I may have a Juniper router and a Cisco router. They can run this OSPF on both and they form neighbor. There is nothing stopping them if they have all the necessary parameters that's supposed to match, for example, the area ID. If the area ID is same in both Juniper and Cisco, if the subnet is same on both Juniper and Cisco, they're going to form neighbor, regardless of this vendor. Open to form neighbor. The readiness. So if you learn OSPF in Cisco, it's the same OSPF in Juniper or anywhere. It's the same OSPF. Only the configuration syntax may be varying, but this, they all are same OSPF, same standard, same topics. I can say in simple words. Whatever you learn here, you learn the same thing there. Same story because it's an industry standard protocol. Open to form neighbor with any vendor. It's not a proprietary one. It's open, shortest part first. And now this protocol comes under a category called link state routing protocol. Link state. OSPF is a link state routing protocol. Link state routing protocol. Why it is called as link state routing protocol? If you see this picture here, all these four routers, they are sending something among themselves. What is that? It's written there, LSA, link state advertisement. They are sending link state advertisement, LSAs. What is link state advertisement? Every router has got a lot of links connected to them, and on each link they got some subnets. Each link will have different subnet. Each link has got some subnet, and this link not only having subnet, it also has got some bandwidth. Every port has got speed, bandwidth, delay, you know, and what else? So based on the bandwidth, there is a there is a there is a variation in, I can say, cost or the metric. See, if you have more bandwidth, then the metric will be less. If you have less bandwidth, the metric will be more. Yeah, the reliability. All these informations of every link is sent as advertisement. We call it as link state advertisement. So router, instead of advertising the routes that they have in the routing table, I repeat, instead of advertising the routes that it has got in the routing table, what do you have in the routing table? The best routes. Correct. In the routing table, you will not have all possible routes to destination. You will have only the best routes in the routing table. Now, these routers, instead of advertising those best routes from the routing table, those routes from the routing table, they advertise the status of every link which are connected to it, using which all other routers will discover the topology. Once they know the topology, every router using that topology that they learned, the map that they learned, they themselves will find the best path and install the best path into the routing table. That's what you see here in this picture. This is the reason why we call this routing protocol as a link state routing protocol. See, we learned EAGRP. In EAGRP, what we saw is advertised distance. Hope you remember. I hope you remember. What is advertised distance? It's the best route of my neighbor given to me from its routing table with a cost, with the composite metric. Using the bandwidth and delay, EIGRP finds the best path and puts that in the routing table. After that, it advertises it to the neighbor, and for neighbor, it becomes advertised distance. Yeah. For neighbor, it becomes an advertisement. Neighbor learns the best route of its neighbor. The router learns the best route of its neighbor. The neighbor is not advertising all possible routes. The neighbor is simply advertising his best routes from the routing table. Where in EIGRP. That's why EIGRP and also the protocol RIP, they're called as distance vector protocol. EIGRP is an advanced distance vector protocol. RIP is a distance vector protocol. The OSPF is a link state routing protocol because the link state advertisement is not just advertising a particular path. No, link state advertisement is everything you advertise. You're not advertising your best route from the routing table. You are advertising every link that is attached to this router and the status of the link, and every router receives it. Say for example, D sends it to C. C learns about this link now, and C now advertises the LSA, including this one and this one. It gives to B. So now B knows about this link, this link, this link, and this link. And then B advertises. Now A learns about this link, this link, this link, this link, and this link, and now A realizes, I am not only connected to B, I'm also connected via D. So we are in a circle. So this not only A realizes, now even D also will realize if that advertisement comes down. So every router now learns the complete topology. So every router will have this as the picture in their memory now. When LSA is advertised, when the link state advertisement is given, instead of giving routing table, when you give a link state advertisement, each router will know about all other router and their links without any link missing. That's not possible in a distance vector protocol. In EIGRP, that's not possible. In EIGRP, routers advertise only the best route. From the routing table, if you advertise the routing table, what do you advertise? You advertise only the best route. So the other routes are not revealed to the neighbor. So neighbor really don't learn the complete topology. EIGRP, even though we see a topology table show IP EIGRP topology, even though it shows a topology table, it's not complete topology table all the time. Maybe in a small network, it may look like it, like you have all the information in the topology table. But in a large network, the topology table will not be a complete table, complete topology table. So in short, what I want to say is the real topology table is only seen if you have a link state routing protocol, because every link with its status, like what bandwidth they got, what subnet is there on it, and what is the cost based on bandwidth, is advertised. So all the routers start advertising as well as they collect LSAs from the neighbor router. I also take information. As a result, after a point of time, everyone will have an identical topology map in their memory. What do we call it as? Link state database. So every router has got a common database. Every router has got a common link state database. And on this database, this SPF algorithm is going to run on each router to find out the shortest path. For example, let's say there is one connection here. Now, in order to come to this point, from here, coming like this is the shortest path. Coming like this. Coming like this is an alternate path. Yes, it's little longer. Right? So this is the picture of a binary tree algorithm, SPF algorithm. So SPF algorithm, which is running on each router's link state database, can provide the low cost path for every destination, and that low cost path is going to be installed into the routing table. So one very important point I want to emphasize, I might have not said it verbally, but I'm saying it verbally now. The routes in the routing table are not the routes learned from others. They are derived, discovered by the router itself. Whereas EIGRP routes that you have in the routing table are not discovered by you. Your neighbor gave you as an advertisement, advertised distance. To that, you added the cost between you and your neighbor, and then you derived one route. Comparing many routes, you picked one low cost path route. So that is dependent. This is independent. EIGRP to decide on a best path, it depends on what the neighbor gives. What the neighbor gives as a route. Neighbor is not giving link state advertisement. In EIGRP, neighbor is giving the route which he has found as the best route. So whatever neighbor gives, based on which you put something on top of it and decide what is good for you. So learning route is only partial in EIGRP because one part of it was done by your neighbor. Your neighbor says, this is my best path and this is the metric for me. Other neighbor says, this is my best path for the same destination and this is my metric for me. Both you receive as an advertisement and you compare and you pick the one which is lower. So that may not be accurate. Also, I said in EIGRP, the routers are not advertising all the links that they got to reach a destination. They are going to advertise you only the best route, which means some of the links are not revealed to you. Maybe your neighbor didn't see a path as important to him, but it may be important for you, which he has not revealed you. For you, it may be important, but for your neighbor, it is not important. He did not advertise it to you, and you will not be knowing it. Whereas in OSPF, every link status is advertised, whether it is good for him or not. He has to advertise me. Whether it is good for me or not, I have to advertise to him. Let him be the judge. Let him pick whatever he likes. Let me pick whatever I like. You just give all the information that you got. I'll give all the information that I got. Let us all do our own work in discovering our path to the destination by having this database. That's a nice approach. Link state protocol decides the route based on the link state database, which is a collection of link state advertisements from all the routers. Because you got the link state advertisements from all the routers, you got a complete picture of topology. With that, you can position, if this is the topology that you discovered, and if you are A, then you position yourself in A. Okay, I'm in A. And if I want to go to this particular link network, I have this path, I have this path. Let me pick this path. Yeah? I can find my own path. On the same topology, to reach here, this router will not take that same path what A has taken. D will say, I have this path as well as this path. Let me pick this path. See, the topology is same, the map is same, the database is going to be same on every router, but the position in which they are in on the map is different. So for me, it is different path. For you, it is different path. See how nice this link state routing protocol. For me, it is different path. For you, it is different path. Same topology we use. See the other protocol that we learned, EIGRP and RIP, they will advertise their best path. According to that information, I need to find my path. How can that be accurate? In this simple example, we see that for D to reach this location, for D it is this direction, for A it is this direction. Now, if A don't have the capability of finding its own path, if A will depend on D for the best path, then A will say this is the best path, which is not. Okay, in simple, what I want to say is OSPF is a link state routing protocol, and the link state routing protocols are more accurate in path selection. The reason is they don't depend on neighbor to give the best route. They simply depend on neighbor to provide all the link and the status. So every router collects the link state advertisement and builds a database called link state database, LSDB, LSDB, link state database. On top of this link state database, so the link state database we call it as LSDB is the topology map, and this map will be identical after a point of time. They should have an identical map, which means they are converged, they are synchronized. They will be identical after sharing LSAs and learning LSAs from everyone. The link state database will be identical. It's like we all go to Switzerland, and as soon as we land in the airport, we collect the map. We three collect collect the map. Now, in our hand, we all three have got same map. Let's say one of you landed in the airport, one of you landed in a bus stand, another one landed in a railway station. So from Germany, we took different transport. You took aeroplane, and he took train, and I took bus to go to Zurich. Now we all got map, but we are in a different location. We all are in same city, Zurich, Switzerland, but our position is not same. I'm in bus stand. You are in airport. You are in railway station. Though we got the same map to reach the hotel, which we three going to stay, a common hotel, IBIS, we are not going to take the same path. The hotel which we are going to reach is same. The city which we are in is same. But the position we are in is not same. So the path that taken by us is not going to be same. Even the map that we got is same. The three have got the same map. But we three take different transport, different path to reach hotel. You got identical map. OSPF helps the routers to build that map, which has got nothing missing. Everything is mentioned in that map, and everyone has got this map. As a result, each router can each router can itself position itself in that map and see all the destinations and decide the best path to each destination and put the best path into the routing table. To decide the best path based on the low cost, the SPF algorithm comes into picture. And now the route is kept into the routing table. You see, from the neighbor, you did not learn route, you just learn the link status. You did not learn for that destination, this is the route. No. From the neighbor, you simply collected a portion of a map, not a route to airport. You just collected a portion of the map, means every single street of the city. Yeah, so link-state routing protocol is the best in picking up the accurate path. Now, same like EIGRP, we see three tables here: neighbor table, topology table, routing table. Let's go from down. Routing table, you know very well, all the best paths for each destinations will be seen there. Using that path, using that best path, using the best path, the packets will be forwarded. So it is a forwarding database. You may be having many paths to the destination, but only the best path that is placed into the routing table can be used. All the other paths that is there in the link state database, what do we have in topology table? The link state database. That link state database may have 100 paths to the destination, but all that cannot be used. If a path needs to be utilized, it needs to be placed into the routing table. So topology table typically refers to the link state database. It consists of all routes and their attached link in the area. I have not spoken about area. We'll talk about areas later. Now what I want to say is it's one cluster of network. Like I said, no Zuri, it's one city. It is not the entire Switzerland. Zuri is a part of Switzerland. So within an area, you will have an identical link state database. Let's say you are in India and you landed in Andhra Pradesh. The map that you got in your hand and the map that I got in Karnataka about India will not be same. We both are tourists. You landed in Hyderabad. I landed in Kempegowda International Airport, Bangalore. We both are provided by an Indian map, but the map is not identical. Why? Because I landed in Karnataka. My map will have more information about the tourist spots in Karnataka. In fact, the other states are mentioned, but not in detail. Other states, more information is about Karnataka. So whoever lands in Karnataka, whether he lands in airport or bus stand or in a railway station, we will all have identical map. But the one who landed in Chhatrapati Shivaji, that is Mumbai. The one who landed in Hyderabad airport, Hyderabad railway station, Hyderabad bus stand, they will all have same identical map because that area is different from this area. They will all have identical map, but both are India map. But more information about Andhra Pradesh will be seen for those who landed in Hyderabad. More information about in Karnataka will be seen for those who landed in Kempegowda and KR railway station and so on. So what I'm trying to say is OSPF is like India. Like you got many states in India, you will have many areas within OSPF autonomous system. Within an area, you can expect an identical map. Within an area, you can expect an identical database. Not countrywide, you can expect. Don't compare the map that you received in Indira Gandhi Airport, Delhi, and Kempegowda Airport, Karnataka, Bangalore. Don't compare and say, don't expect to be same. Though it is India map, it won't be same. Within an area, the LSDP is going to be same. So that is topology table. The neighbor table will have the list of all neighbors with which the adjacency is formed. See, to form adjacency, there are some parameters. Only those routers that have fulfilled those parameters can become adjacent routers, neighbors. Those neighbors will be listed in this table. So link state database has got neighbor table, topology table, and the routing table, 3 tables. The real topology table is seen in OSPF, not in EIGRP. Again, in OSPF, within an area, you will have accurate, identical topology. Don't expect throughout the autonomous system. All right, as I said, OSPF is a link state routing protocol. Link state routing protocol will have more information about the networks and their metrics compared to the EIGRP and RIP protocol, which is distance vector. So compared to the distance vector, counterpart to distance vector, link state routing protocol has got more information. As a result, You can pick the best path for every destination. Best path, accurate decision can be taken because you got the complete picture of that area, because you got the very clear routes of that area, not someone giving only partial route. When you land in a new place, if you have a map, you can have your own path selection. Instead, if you are dependent, if you don't know that there is something called map, what you might have done, you might have asked how to go to that place, and someone might have said, go this way. According to that someone, that is the only way best. He gives you and you follow it. That may not be accurate. You see, EIGRP, RIP, they're all distance vector protocol. This is like you land in some place and ask the roadside guy, do you have any information about this destination? For example, you landed in Bangalore airport and you ask, how can I go to Chinnasamy Stadium in Bangalore? Chinnasamy Stadium. And he knows only the person whom you asked, he knows only one path, and he will give that path. For him, that is the best path because he lives in the other side of Bangalore. For him, that is the best path. But you are now in this side of Bangalore. If you follow his path, then it is going to be a long distance because for him, from the other side of Bangalore, that is the best path, which is not accurate. But when you got the map, you can position yourself in the airport and you can find the best path by tracing the routes drawn in the map. So in short, what I would like to say is link state routing protocols helps us to make accurate path selection. As I said earlier, link state routing protocol follows a hierarchical design, like you have many states and you got one capital for each country. You got here area 0 and non area 0, meaning like you have a central government and many state governments. We got two level hierarchy, central government, state government. This is central government, area 0, which is also called as transit area or backbone area. See why it is transit area? If one state wants something from the other state, they go through the central government. They don't talk directly. Policy don't agree. They go through the central government. The two state governments cannot talk and solve their problem. If they do that, then why there is need for a central government? What will they do for bua, for eating? They also need money, no? So they will come in between. So you need central government to make some people live. Central government is always a transit. for two state governments. That's why we call them as backbone, Area Zero. All the states are called as non-backbone areas, regular areas. Exactly what I said is what you see in OSPF. No two areas can interact. If they want to interact, they need to interact through the top of the hierarchy, the central government. There are many routers, many networks inside. Now, the only reason why you got area zero is to be a intermediate broker between areas. There is no other job of area zero. Without this area zero, you cannot communicate. That is a policy. Area zero should go through area, sorry, area 10 should go through area zero in order to talk to area 20. This two level of hierarchy helps to have a big autonomous system, big nation, big autonomous system. If a state is not performing well because they're all illiterate, how the state runs? They take money from other state GDP and make these lazy guys eat. We feed. That's how we balance. Exactly the same thing happens even in OSP. We got multiple areas and we got one backbone area. All area must go through area zero. And area zero, the number zero is only for backbone, reserved for backbone. Other numbers you can use for non-backbone areas. There is no reservation. Only for backbone, zero is reserved. So two level of hierarchy, transit area, regular area. All the regular areas go through the transit area. What is the purpose? You can localize the impact of an area within that area. For example, if there is an issue in a state, that issue will not spread to other state. It will be localized. If you don't have areas, if India is one big country, then a small issue in one corner will impact everyone in India. Because we are divided in states, an issue happening in one place may impact the entire state, sometimes the neighboring state. Say, for example, a big train accident happened. It might be a news for many in India, but it may be a very serious impact for few in Karnataka, in Tamil Nadu, because the train was coming towards this to destination. So the issue is localized because they are divided in states. Of course, there is nowhere safety, no airlines or roadways or trainway, waterway, nothing is safe. We need to protect ourselves. We cannot fully rely on all these transports for our safety. So this area solves a lot of problem. You see, if any small network goes down here, it will only impact within that area. It won't go to other area because we will do summarization here for all the networks. So because you do summarization, the routing table of the other area is not going to be utilized more by this area. Area 1 routes are summarized and sent as a result. The minimized routing table entries will be seen. So you get a summarization point. If you don't have areas, you will not have summarization point. Minimize the routing table entries. Not only that, localize the impact of topology change within an area. If any small change happens, that is localized within an area. Because you do summarization, that small change will not go out. Detail LSA stops flooding at the boundary. That's what I just said. Detail, instead of sending detail LSA, you send summary LSA. All right. So for these good reasons, we need the hierarchical design. So area 0 is good because you got area 0. You can summarize and send to area 0. All the areas send only the summary route to area 0, and area 0 takes it and distributes to other areas. So area 1 learns about area 2 and 3 in a summarized way from whom? From area 0. Likewise, area 3 learns about area 1 and 2 from B router, which is area 0. So what we have learned here is OSPF is a link state routing protocol. It uses SPF algorithm. O here means open standard. Link state advertisement, link state database makes this protocol more efficient. It can make accurate path selection. We've got 3 tables: neighbor table, topology table, and routing table. And OSPF follows the hierarchy design. Area 0 is a transit area, which is also called as backbone area. Without this transit area, backbone area, no possible of communication between non-backbone regular areas. All right, so we understand why we need areas. Because you got areas, you got borders. Within a country, you got borders. It's because you got states. Otherwise, there won't be borders. You cannot do summarization. This is Kaveri issue. Tamil Nadu, Karnataka. Boom. It won't impact any other states. This is Meghdadu Dam. Boom. Karnataka, Kerala, and Tamil Nadu. See, you got borders because of that. The localizing the impact of topology change. Detailed LSA stops at the area border. All right. We stop here. Any question on this?